today's lab, we are going to investigate Newton's second law using an air track. We are also going to learn a new piece of computer software.
In our past labs, we have made fits to data in Logger Pro. Logger Pro uses an algorithm to apply a method of least squares fit to our data. Every time we take a measurement, we have an uncertainty associated with it. If we create a graph of how something in y changed with x, we can see uncertainty as error bars. Here, I had a really hard time taking data in that last measurement, so I am much less certain. This data looks fairly linear, so I could decide how I might draw a line through the points. If I try to get through everything, I can see I really miss the upper points of data. However, if I notice that the last point is very uncertain and ignore it, I can get a much better line drawn through my data. Unfortunately, Logger Pro does not contain a weighted least squares fit algorithm, but we have another program that does, SigmaPlot, where there is a macro written by Gustavus physics professors to do a weighted fit in y and in x called ModelFit. The first part of the lab will be exploring ModelFit with test data. In the last piece of our analysis, we will be fitting our data with ModelFit. You can fit using functions such as polynomials, exponentials, power fits. There are not as many models as there are in Logger Pro, but all the important functions used in physics are here.
Remember, when you use an air track, you first want to make sure that it is level. Once it is level, you can start performing the experiment. Here we will use an air car with a force sensor attached, with a string that goes around a pulley, and on the other end of the string there will be a hanger with a mass attached to it. This is a smart pulley. It measures position versus time of the string as it passes over the pulley, and therefore position versus time of the weights and the car to which the string is also attached. The smart pulley uses a light detector to record the position and time whenever one of the spokes passes through the photo gate. Next, you will vary the string tension by adding mass to the hanger. You can do this for a series of runs and then make a plot of acceleration versus tension in SigmaPlot using ModelFit. The information in the slope will tell you something about the mass of your air car. You can compare this to what it actually is massed at when you put it on a scale. What kind of shape do you think that Logger Pro is going to plot here for position versus time? Remember, the car is accelerating down the air track. That's right, a parabola. And how would you fit to this parabola? Yup, you got it, a quadratic. So in Logger Pro, that is x is equal to at squared plus bt plus c. And if we want to think about the equation of motion that this corresponds to, well, that is just position is equal to 1/2 acceleration times time squared plus initial velocity times time plus our initial position. So we can see how these coefficients here correspond to these variables. So here, how do we find acceleration? That's right, acceleration is just equal 2 times the coefficient capital A. But Logger Pro will also give us some uncertainty for this A. We will have A plus or minus some uncertainty in A. If acceleration is just twice this coefficient, what should we do for the uncertainty in our acceleration? That's right, you just double it. The uncertainty in our acceleration is just twice the uncertainty of coefficient capital A.